Math Blast 34, determining the unknown. Fill in the missing factor. Factors are numbers that we multiply together to get a product. 7 times what is equal to 35? Or otherwise stated, 7 groups of what gives us 35. 7 groups of 5 equals 35. 36 divided by 6 equals what? If I have 36 total items and I divide those or equally share them among 6 groups, I will find that there are 6 in each group. So 36 divided by 6 is equal to 6. 64 equals 8 times what? 8 groups of what is 64? 8 groups of 8 equals 64. 10 is equal to what divided by 6? I'm going to use a related multiplication fact here. If something divided by 6 equals 10, then 10 times 6 is equal to that something. So 60 divided by 6 is 10. Distributive property. Show an array for 6 times 3 equals what? Using the distributive property. Well, an array for 6 times 3 is 6 groups of 3, which is 6 rows of 3 here. Six groups or rows of 3. Now, using the distributive property says I can take this array and I can break it into 2 smaller arrays, 2 facts that may be a little easier to deal with. I'm going to break it right across the middle here and have a 3 by 3 array and another 3 by 3 array. So I can show that using the distributive property. 6 times 3 is equal to 3 groups of 3 plus another 3 groups of 3. So 6 times 3 is equal to 9 plus 9. We can conclude that 6 times 3 is equal to 18. Two-step word problems. Adam found 7 frogs on Monday and 8 frogs on Tuesday by the pond near her house. Each frog had 5 warts. How many more warts did frogs have on Tuesday than on Monday? Step 1, I'm going to show on Monday that there were 7 frogs. I'm going to draw a tape diagram here with each box representing a frog. And we know that it says there are 7 frogs on Monday and each frog had 5 warts. So I'm going to put a 5 in each of the boxes representing a frog. The 5 then represents how many warts were on that frog. So I can determine the total amount of warts for Monday here by taking 7 groups of 5, which equals 35. Then for Tuesday, we're told that there are 8 frogs. So I'm going to show my 8 frogs here. Each box will be a frog, and inside of each box there will be a 5 for the 5 warts that that frog has. And to determine the total amount of warts for Tuesday, we can take 8 groups of 5 and find that there were 40 warts on Tuesday. Now, we haven't answered the question yet. The question is, how many more warts did the frogs have on Tuesday than on Monday? So we can see the difference here. There's this extra box on Tuesday than on Monday. And we can show that mathematically as 40 minus 35 equals 5. I want to make a statement that on Tuesday there were 5 more warts than on Monday. Multiplying multiples of 10. 5 times 60. Well, 5 times 60 is 5 times 6 tens. 5 times 6 is one of our basic facts, 30. So 5 times 6 equals 30, but we're dealing with tens here, so it's 30 tens. In standard form, that's 300. 4 times 90 is 4 times 9 tens. 4 times 9 is our basic fact of 36, but again, the units here are tens. So it's 36 tens, which is 360. Equivalent fractions. Using the number lines shown, what is the equivalent fraction to 1/4? I'm going to see what each of the units are for the number lines. 0 to 1 is a whole. That whole is broken into 3 equal parts. So the units here are thirds. 0 thirds, 1/3, 2/3, and 3/3 is 1 whole. For my second number line, 0 to 1, again, is my whole. I am breaking that whole into 1, 2, 3, 4 equal parts. So the units are fourths. 0/4, 1/4, 2/4, 3/4, and 4/4 is 1 whole. And for our last number line here, the whole, 0 to 1, is broken into 1, 2, 3, 4, 5, 6, 7, 8 equal parts. Our units are eighths. 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8 is 1 whole. The question is, using the number lines shown, what is equivalent to 1/4? So 1/4 is here. Any of the tick marks that line up with that 1/4 would be equivalent to it. So we can see that 2/8 is equal to 1/4. On the back side, today we are comparing fractions. Compare the fractions using greater than, less than, or equal. Justify using the fraction models. I have 2/2 versus 2/6. My 2/2 means there are 2 equal parts in the whole, and I have both of those parts shaded. My 2/6 means there are 6 equal parts in the whole. 2 of those are shaded. Now I can use that to help me with my comparison here. What I see here is that I have 2, the same number of units in each model. It is the size of each unit that we're comparing, because these units are halves and these units are sixths. So the sixths are smaller because we had to break our whole into more pieces. So 2/2 is greater than 2/6. Here I have 1/5 versus 4/5. I'm going to break the whole into fifths. 5 equal size pieces. I have 1/5 shaded in my first model, and I have 4/5 shaded in my second model. Now for this problem, we have the same size units. The denominator is fifths for both fractions. So our actual units are the same size. It's the number of those units that we're comparing. 1 of the fifths versus 4 of the fifths. 1/5 is less than 4/5. The area of rectilinear figures. Find the area of the figure. Labeled measurements are in inches. Here I see that I have 2 rectangles. I have area as length times width when I'm dealing with rectangles. So to find the area of this composite figure, I'm going to take the 2 rectangles and find the areas individually and then put them together. So the area of this rectangle here is 4, and we said inches are the units. So 4 inches times 6 inches. The area of this second rectangle over here is 5 inches times 4 inches. Now my first rectangle here, 4 inches by 6 inches, is equal to 24 inches squared, square inches. And the area of my second rectangle here, 5 times 4 is 20. And our units, inches times inches, are square inches, or inches squared here. Now I want to take the two and put them together. The area of the composite figure is 24 inches squared plus 20 inches squared. That means that the actual area is 44 inches squared. Or you might see it as 44 square inches. Those mean the same thing. Okay. Check all that apply for the given shape. Here I see a shape that is a quadrilateral. It has 4 sides. It is a trapezoid because it has at least one pair of parallel sides, meaning when those sides extend, they will never intersect each other. It is also a parallelogram because it actually has 2 pairs of parallel sides. Opposite sides are parallel on the quadrilateral there. Rectangle has 4 right angles, and in this case, our shape that's given does have 4 right angles, so it is a rectangle. A rhombus is a quadrilateral that has 4 equal sides, and I notice on the figure that we're given, there are 4 equal sides. And a square is a rectangle and a rhombus. It is a quadrilateral that has 4 right angles and 4 equal sides, which we've already determined to be true here. So the most specific name for our given shape is a square.